Mathematics is everywhere. Everything can be attributed with the science of numbers. Also, mathematics is the language of various sciences like chemistry, physics, astronomy, and many others. Learning math is learning how this world operates. In today's lesson, we will connect mathematical concepts with various real-life situations. Good day, students! Welcome to our first learning episode for Senior High School General Mathematics, where you will be given enjoyable and relevant activities. I am Sharina D. Ejercito, and I will be your guide in achieving today's learning objectives. Let's start by looking at the following diagrams. The first diagram shows the number of kilos of rice consumed for a specific period depends on the number of members in the family, while the second shows that the dollar equivalent in peso depends on the current exchange rate, and the last shows that the wage of worker depends on the time spent working. Now, let's think of a word or words that could best describe the situations presented from the three diagrams earlier. What word or words could you think of? You might have probably thought of the words connection, relation, or correspondence. In mathematics, whenever we consider such terms, we are referring to the concept of functions. Our lesson for today will focus on functions. Specifically, we are going to achieve the following objectives. Represent real-life functions, including piecewise functions. Evaluate a function, and solve problems involving functions. In order for us to get along well with the lesson, I want you to have your pen and paper with you, as well as your learning activity sheet in general mathematics. Buckle up and let's have fun learning today's lesson. Let's start with the definition of function. Function in mathematics is a relation from a set of inputs, also called the domain or the set of x values, to a set of possible outputs, also called the range or the set of y values, where each input is related to exactly one output. This relationship is commonly symbolized by this functional notation, read as f of x is equal to y. In addition to f of x, other abbreviated symbols such as g of x and p of x are often used to represent functions of the independent variable x, especially when the nature of the function is unknown or unspecified. There are different ways in representing a function. It could be represented using set of ordered pairs, table of values, mapping diagram, graph, or equation. There are different types of equation, and some were already presented to you when you were in junior high school. Some examples include polynomial functions, rational functions, radical functions, exponential functions, logarithmic functions, trigonometric functions, and piecewise functions. One problem which we must solve along function is to determine whether the given representation is a function or not. Let's start with the set of ordered pairs, table of values, and mapping diagrams. Given set A with ordered pairs, negative 1, 2, 1, 2, 2, 3, 4, 8, and set B with ordered pairs, 1, 1, 2, 3, 1, 6, 3, 2, which set represents a function. To answer this, we must remember that for a relation to be considered as a function, Each input must be exactly paired to only one output, or x coordinate should never appear more than once in a given set. For that matter, set A is a function because each input is exactly paired to only one output, while set B is not a function because two ordered pairs have the same input that is paired to different output. How about this table of values? Is it a function or not? It is a function because each input is exactly paired to only one output. Now let's focus on this diagram. Does it represent a function or not? It is a function because no same input is mapped to the set of output. Let's now proceed to graphs. In order for us to determine whether a graph is a function or not, it should be subjected to vertical line test. Vertical line test is used to determine if the graph is a function or not. A graph represents a function if and only if each vertical line intersects the graph at most once. Let's take a look at the following examples. As you can see, when a vertical line was drawn on the graphs, the line intersected the given graph at exactly one point. When this happens, the given graph is a function. Otherwise, it is not a function. How about if the given are equations? How are you going to determine if it is a function or not? One way to determine whether an equation is a function or not is by looking at its corresponding graph. For example, the equation y is equal to 5x plus 3 is a function because its graph is represented by a line which would certainly pass the vertical line test. Those are the different ways in representing functions. I hope everything's clear on that part already. This time, let us go back to the definition of function. Earlier, we have defined function as a relation from a set of inputs to a set of possible outputs where each input is related to exactly one output. We can visualize this definition using a function machine. Let us take the function y is equal to 5x plus 3 as an example. As you can see from this diagram, any real number input denoted by A can be processed inside the machine. The output would be 5A plus 3. If the input is 3, after processing, the output would be 18. The process which was applied is probably familiar to you. This is called as the substitution method. Whenever you are doing this, you are evaluating functions. Evaluating a function means replacing the variable in the function, that is, replacing the x variable with a value from the function's domain and computing for the result. This process usually applies the substitution method. Let's take a look at the following examples. Given the function f of x is equal to 2x plus 1, where x is equal to 2, we substitute 2 to the variable x in the given function. This gives us f of 2 is equals to 2 times 2 plus 1. Simplifying, we get f of 2 is equal to 4 plus 1 which is equivalent to f of 2 is equals to 5. This time, consider the function h of x is equal to the square root of the quantity of x plus 1, where x is equal to 0. Let's replace all variable x with 0. This gives us h of 0 is equal to the square root of the quantity of 0 plus 1. Simplifying, we get h of 0 is equal to the square root of 1, which is equivalent to h of 0 is equals to 1. There are other examples found in your learning activity sheet. Examine them and analyze how the results were derived. Your teacher is very willing to answer your queries regarding the examples presented. Functions can often be used to model real-life situations. This helps us understand various phenomena if we have an appropriate functional model. Some situations or phenomena can be described by using more than one formula. We call this as the piecewise functions. Piecewise function is a function where more than one formula is used to define the output or the range over different pieces of the input or the domain. An example of piecewise function is f of x is equal to x squared if x is less than 2, 6 if x is equals to 2, 10 minus x if x is greater than 2 but less than or equal to 6. In this function, the expressions x squared, 6, and 10 minus x are called sub-functions, while x less than 2, x equals 2, and x greater than 2 but less than or equal to 6 are their intervals respectively. Let's have a real-life example of piecewise function. A parking garage charges 6 pesos for the first 4 hours that a car is parked in the lot. After that, the garage charges an additional 3 pesos an hour. Write a piecewise function for the cost of parking a car using the function t of x, where x is the number of hours parked in the garage. Let us first focus on the first sentence. It says that a parking garage charges 6 pesos for the first 4 hours that a car is parked in the lot. It means that 6 pesos will be asked if a car is parked for 4 hours. 3 hours, 2 hours, 1 hour, or even for 30 minutes. If x is the number of hours parked in the garage, then the sub-function and its interval is represented by 6 if x is greater than 0 but less than or equal to 4. Meanwhile, the second sentence states that the garage charges an additional 3 pesos an hour after 4 hours. Since x is the number of hours parked in the garage, the expression representing the additional charge is 3x, and this is to be added to the fixed charge, which is 6. Therefore, the second sub-function and its interval is represented by 6 plus 3x if x is greater than 4. Because of that, the piecewise function representing the situation is f of x is equal to 6 if x is greater than 0 but less than or equal to 4. 6 plus 3x if x is greater than 4. Great! You are now ready to answer some problems related to what I have discussed. Kindly get your paper and pen and try answering our first set of problems. For the first set, determine whether the given is a function or not. Write your answers on your answer sheet. Let's check. The first item is not a function, while the second and third items are functions. Let's proceed to the next set of problem. For the second set, you are going to evaluate the following functions. Time's up. Let's check. For the first item, the answer is f of 2 is equals to 5. For the second one, f of negative 2 is equals to negative 1 is the answer. While for the third item, the answer is h of 24 is equals to 5. Were you able to get all the items correctly? That's great! It means you really earned something from today's lesson. If not, you can still review your learning activity sheet and go back to the part which were quiet and clear to you. Your math teacher is very much willing to help you. If everything's already clear to you, you may proceed to the evaluation part of the learning activity sheet. Once done, submit your answer sheet to your teacher. And that is the end of our lesson today. I am very happy that I am with you in this amazing learning journey. I hope you had fun learning. Until our next lesson in general mathematics. Take care, and as always, enjoy learning.